Hello everyone, welcome back to my channel Learn with Simran. In today's video, we are going to talk about the crucial concepts of machine learning, bias variance trade-off. At first, I know it sounds very confusing, but I promise by the end of this video, you will have a clear understanding about bias, variance, and the trade-off between them. So let's not delay it further and get the learning started.
Imagine we have a dataset with features x and y, where x is used to predict the values of y. Let us say we have already done our data cleaning and data pre-processing, and now we are ready to build our model. We will start by splitting our dataset into training data and testing data. We will use 80% of the data for training our model and 20% for testing it. The idea behind split is to train the model on one part of the data and evaluate how well it performs on new, unseen data using the test set. First, we will train a model using the simplest machine learning model available. Once the training is done, we check the error or how far off our model's predictions are from the actual values. This is known as the training error. After that, we test the model on the 20% of the data we saved, called the test set, and check the test error. Here's the tricky part. We might see that the test error is significantly higher than the training error. This tells us that the model has failed to learn the relationship between x and y. It is a sign that the model is underfitting. Underfitting happens when the model is too simple to capture the patterns in the data. A good example would be using a straight line to fit the data that actually follows a more complex curve. The model is not flexible enough, and so it makes wrong predictions both on training and testing data. In this case, our model has high bias and low variance. High bias means the model is consistently wrong. It has made strong but incorrect assumptions about the data. Low variance means it's making the same type of mistake across different datasets. Now let us go to the other extreme. Let's say we choose a more complex model with many parameters. When we train it on the training data, we see that the training error is almost zero. Awesome, right? But hold on. When we check the test error on the unseen data, it's much higher. What just happened? Well, our model has memorized the training data instead of learning the underlying patterns. And this is called overfitting. In this case, we have low bias but high variance. Low bias means the model fits the training data well, but high variance means it's too sensitive to small fluctuations in the data and it performs poorly on new unseen data. Now let's break down the error into three parts: bias, variance, and noise. The total error is a sum of these three components. While we can't do much about the noise, which is random errors in the data, we can work on reducing bias and variance. Bias is the difference between the predicted values and the actual values. It shows how far off our model is on average. Whereas variance tells us how much our model's predictions change when we use different training datasets. High variance means the model is unstable. So what do we need to do to reduce this total error? Well, this is where the bias variance trade-off comes in. When we reduce bias, variance tends to increase. And when we reduce variance, bias tends to increase. It's a balancing act. So this graph is a well-known representation of the bias variance trade-off in machine learning. On the x-axis, we have a model complexity. This refers to how simple or complex our model is. On the y-axis, we have the error. This could be the total error that our model produces. Let's talk about the red line, which is the bias. As the model complexity increases, the bias decreases. This makes sense because a simple model like a straight line has high bias. It makes large assumptions about the data. But as we increase the complexity of the model, bias reduces because the model becomes better at capturing patterns in the data. Now let us talk about the green line, which represents variance. As the model complexity increases, the variance increases. This happens because a very complex model starts overfitting the data. It becomes too sensitive to even the smallest fluctuations, leading to high variance. The blue line, which represents the total error, is a combination of both bias and variance. When we are on the left side of the graph, the underfitting zone, leading to the high bias and low variance. While when we are on the right side, the overfitting zone, the model is too complex, leading to low bias but high variance. The sweet spot is in the middle where the total error is minimized. This is the optimal solution where both bias and variance are balanced to get the best model performance. Hope you have understood how to find the optimal solution for your model in machine learning. Now let us talk about the bullseye diagram for visualizing bias and variance in a simple way. Imagine the inner circle in this diagram is the bullseye. When we talk about the high bias and low variance, the underfitting zone, the predictions are far from the bullseye but close to each other. This shows that the model is consistently wrong but makes similar mistakes every time. Whereas when we talk about the low bias and the high variance zone, the predictions are scattered all over the board. Some are near the bullseye, some are far, but there is no clear pattern. The model fits the training data too well but performs poorly on the new data. This represents the overfitting. And when we talk about the low bias and the low variance zone, the predictions are tightly clustered around the bullseye. This is the ideal scenario where the model makes accurate and consistent predictions. This is the optimal model. And when we talk about the high bias and high variance zone, imagine arrows are scattered far away from the bullseye and also far from each other. This represents a model that is both inaccurate and inconsistent. It's the worst case scenario because the model is making large errors consistently and in unpredictable ways. This is the worst case scenario for your model. So the bias variance trade-off is all about finding the balance between bias and variance. The graph we just saw and the bullseye diagram both show us that we want to avoid both underfitting and overfitting. We want a model that has just the right amount of complexity, enough to capture the patterns without becoming too sensitive to the noise in the data. In summary, the bias variance trade-off is about finding the right balance. You don't want your model to underfit with high bias and you don't want it to overfit with high variance. The goal is to strike a balance where the bias is low enough that the model learns the pattern and the variance is low enough that it can generalize to new data. And that's the beauty of the bias variance trade-off. By understanding this, we can build models that not only perform well on the training data, but also on unseen test data.
If you have found this video helpful, do like, share and subscribe to my channel Learn with Simran. Thank you so much for watching. Keep learning. Bye bye.